armature control DC motor. So for armature control DC motor, we can develop the state model. We will see how to develop the state model. And we know that the block diagram of armature control DC motor, from the block diagram we will develop the state model. And if you recollect the block diagram which we have derived already, the state model block diagram, that block diagram is like this. Okay, this is a block diagram of armature controlled DC motor. Now what are things that we have? We have a forward path and also there is a feedback path. What are the elements in forward path? We have 1 by LAS plus RA, which is the term related to the electrical system, and followed by KT, which gives the relation between electrical mechanical, that is a torque constant. Then we have the mechanical system 1 by J S square plus BS, that is the model of the mechanical part of the DC motor, and there is a feedback. This feedback is because of the back EMF, that is KB. KB into S. Now we have negative feedback. The input is VA armature voltage, output is my theta displacement. So displacement is output and armature voltage input, and based on the armature voltage and your theta is going to be vary. Now, so how can we develop the state model for this block diagram? Now let us take the mechanical system 1 by Js square plus Bs. I can take S common the denominator and you can write separately, and when you write separately, this is a change which we want, 1 by S. Now again what I want is, I want to shift the takeoff point after 1 by S to the before 1 by S. Then if you do that, then in the feedback we need to introduce one more block with 1 by S, and SS gets cancelled. The feedback, that will be only KB, which is a back EMF constant. So now the complete block diagram looks like this. We have already electrical system, there is a constant, and also we have mechanical system, but here I have 1 by Js plus B, and there is a feedback, and after that we have 1 by S, and the last output variable is theta. So output variable is theta, before the integral derivative of that which is omega. So angular velocity, and also we have other terms. Now what I want is, I want to define the state variables for this. If you define the state variables, then we can write the equations easily, then we can get the state model. So what I am doing is, I am coming from the right side. After the integrator, what are the variable available, that is I am taking as x1, and before the integrator is x1 dot. And let us take the KT and multiply with the second and third blocks can be multiplied, KT by Js plus B. Now for this, it is a first order term. For this first order term means we need to represent it as a 1 by S, one integrator. Therefore output of this will be one state variable, and input to this will be another state variable. So x2 dot. Again electrical system x3 dot. So we can take like this, then we will write the equations. So when you look at equations, what I am doing is, I am writing first x1 dot is equal to x2. x1 dot is x2. This is equation number 1. Then when you look at the second, what I can do is, already block is available, output and input we have. I just want to write the relations. So what I can do is, the x2 dot is nothing but x3. So I want to get x2 by x3 relation. So what is x2 by x3? x2 by x3 is KT by Js plus B. Then you just cross multiply them, and what I want to write x2 dot separately. When you write x2 dot separately, that is going to be K1 x3 minus Bx2 divided by J. So again you separate them, because we know x3 is a one state variable, x2 is another state variable. So I can write Sx3 which is Sx2 which is x2 dot. So x2 dot is KT by J into x3 minus B by J into x2. So this is a second equation. Similarly, I can take the first electrical system 1 by Js, 1 by LAS plus RA. For that output is nothing but my x3 and input is x3 dot. So in place of x3 dot, let us take this another variable m. So x3 by m I want to write the equation. So x3 by m is nothing but 1 by LA plus RA. So again when you look at m, that m is nothing but which is output of the summing point. What is that? It is a difference between the VA and as well as the KB into x2. So m is Va minus Kb into x2. In place of m, I am going to replace this and rearrange them. So if you rearrange them, then you will be getting the finally x3 dot. x3 dot is nothing but Va by La. Va is input and La is my another constant minus. So we have Kb by La into x2 minus again we have Ra by La into x3. So this is the third equation. So with these three equations we can develop the state model as like this. So what is x1, x2, x3 is the variables, their derivatives, and what are the entries of A matrix. If you look at the entries, first row is 1, 0, 1, the second row is 0 minus B by J and minus KT by J, and third row is 0 and KB by LA, and also we have RA by LA. Then what is the B matrix entries? We have 0, 0 and 1 by LA. We know what is the output. The output is nothing but my angular displacement theta, and we know that theta is, before that we have x1 variable, state variable, so we can write as theta is equal to x1. Then we can write it as theta is 1, 0, 0, x1, x2, x3 plus 0 into Va. So this is C matrix, this is D matrix, and A matrix, B matrix available, A, B, C, D matrices, which gives the state model of armature control DC motor.